Section 2.6, Input-Output Models. We use input-output models when we are concerned with the production and flow of goods. We consider those goods or commodities as the input. The amount of each commodity produced is given by the production matrix. To satisfy the demand from outside production systems, we have a demand matrix. Since we will allow for a surplus of products, we will use an open model to find the production model. If you would want to leave no leftovers to satisfy further outside demands, we would utilize a closed model. In this section, we're only going to be concerned with open models. The production matrix is given by the production matrix is equal to the identity matrix minus A, so minus our A, take the inverse of that, and then multiply it by the demand matrix, where I is the identity matrix. Remember, an identity matrix is where we have ones in our diagonals and everywhere else is zeros. Let's find the production matrix of the following input-output and demand matrices using the open model. So, our formula, remember, is so the identity matrix minus our A matrix, find the inverse of that, and then multiply it by our demand matrix. So we first want to take our identity matrix. So we have a 2 by 2 with A, so we're going to take a 2 by 2 identity matrix, so 1, 0, 0, 1, and subtract 0.8, 0.2, 0.2, 0.7. This will result in 0.2, so 1 minus 0.8 is 0.2. Nothing minus 0.2 would be negative 0.2. Nothing minus 0.2 is negative 0.2. And 1 minus 0.7 is 0.3. Alright, so now we need to find the inverse of this. So note that we take 0.2, negative 0.2, and 0.3, and we add on the identity matrix here. But I don't know about you, but I'm not quite a fan of decimals. So I'm going to multiply every item by 10. So 0.2 times 10 gives me 2, negative 2, 10, 0, negative 2, 3, 0, and 10. So this helps get rid of the ugly decimals. So I want to start I need a 0 in my negative 2 spot here. But I can see that if I were just to simply add these together, that would happen. So I'm going to add my top row to my bottom row to replace my bottom row. So nothing's going to change in my top row. But if I add my top row to my bottom row, I'll get 0, 1, 10, 10. Alright, I now need to get a 0 in the negative 2 position. So I'm going to multiply my bottom row by 2 and add it to my top row. So nothing's going to change in my top row. But my bottom row is going to be 0, 2, 20, 20. So when I add these together, I get 2, 0, 30, 20. So this is now my new top row. And again, nothing changed on my bottom row. So I know I need to have ones in my diagonals. So I'm going to need to divide my top row by 2. And my 1 is already in my bottom row, so I don't need to do anything with that. So if I divide my top row by 2, we'll have 1, 0, 15, 10, and 0, 1, 10, 10. So we just found the inverse. So at this point, we have done this portion of our equation. The last part is to multiply the inverse by our demand. Okay, so I'm going to erase a bunch so that we can do our inverse by our demand. Our inverse matrix was 15, 10, 10, 10, and we're going to multiply that by 2, 3, our demand. So we have a 2 by 2 multiplied by a 2 by 1. So these match, so we're going to result in a 2 by 1. Alright, so take our top times the left there. So 15 times 2 plus 10 times 3. So 30 plus 30 gives us 60. And now we will do our bottom by the left there. Ooh, it kind of erased a little bit. Let's choose a different color. Here we go. So we'll do 2 times 10 plus 3 times 10, so 20 plus 30 giving us 50. So here is our production matrix. Let's find the production matrix for the following input, output, and demand matrices using the open model. So we have some more decimals, which is common. So first I need to take, according to our formula, we need to take our identity matrix minus our A matrix, find that inverse, and then multiply it by our demand. So we have another 2 by 2, so our identity matrix is 1, 0, 0, 1, and we're going to subtract 0.1, 0.03, 0.07, 0.6. So when I subtract, I will get 0.9, a negative 0.03, negative 0.07, and 0.4. And now to find the inverse, we need to add the augmented matrix with the identity matrix. But I don't like those decimals, and I'm pretty sure you don't either. So it looks like my smallest decimal is 100th. So I'm going to multiply this whole item by 100. So moving our decimal over 2 spaces with each item, we'll get 90, negative 3, 100, 0, negative 7, 40, 0, and 100. We're going to get some kind of big numbers here, so be patient. I need to get 0 in the negative 7 position, so I'm going to multiply my top by 7 and my bottom by 90. 1 is already negative, so I don't need to include a negative, and then add the top to the bottom. So if I multiply everything on the top by 7, I will get 630, negative 21, 700, 0, and multiplying everything on the bottom by 90, we will get negative 630, 3600, 0, and 9000. So when I add these together, I'll get 0, 3579, 700, and 9000. So that will be my new bottom. Kind of large. Now I need to replace the denominator, my negative 3, with 0. So I can, let's see here. If I divide 3579 by 3, it's 1193, so it comes out evenly. So I won't need to multiply both my numerator, both my top and my bottom by that. So I'm just going to multiply my top by 1193 and add my bottom to it. So when I multiply my top by 1193, I will get 107, so 107,370, negative 3579, 119,300, and 0. I didn't need to multiply anything on the bottom, so it's just going to be 0, 35, 79, 700, and then 9,000. So when I add these together, we'll get 107,370, 0, 120,000, and 9,000. So I'm going to erase some stuff here. I'm going to replace my top row with my new number here. So then we can kind of finish it up. So here I've replaced my top row with all those large numbers. We need to get our diagonal equivalent to 1. So I know this is going to be daunting and kind of scary, but I need to divide my top row by 107,370, and I need to divide my bottom row by 3579. So that we get 1001. And I'm just going to leave them in fractional form. I'm sure they can be reduced, but just so you can see what it looks like. So now we've found our inverse. So we've done this portion. We now need to multiply this portion here by our demand matrix. Okay. So I'm just, instead of writing a new row, I'm just going to leave it as such. So we're going to take our top and multiply it down here. And you're going to need to use your calculator to verify some of this information for us, okay? So don't be shy. Pause as you need and figure it out as we go here. So multiply that by 5. Add that to 9,000. And we're going to get some decimals here. So if you were to use your calculator and take 120,000 by 5, you're going to get an even bigger number, and then divide that by 107,370, we're going to get 5.588. Okay? And we're going to add that to, if we take 9,000 times 10, whatever that number is, a larger number, divide that by 107,370, we will get a decimal, 0.838. So if we add these two decimals together, we get 6.43. So our production matrix so far is 6.43. Again, we have a 2 by 2 multiplied by 2 by 1 will result in a 2 by 1. Alright, so now we need to do the bottom portion. So I'm going to erase this part here so we can multiply our bottom. So we're going to take our bottom by the right-hand side. So we're going to take 700 over 3579 multiplied by 5 and add that to 9,000 times 10 divided by 3579. Again, we're going to get some decimals. So take 700 times 5 and divide that by 3579, and you should get 0.978. On the right-hand side, we're going to take 9,000 times 10 and then divide that by 3579. Again, you should get a decimal. A larger decimal, but still a decimal. So if we were to add those two together and round, we will get 26.12. So our production matrix is the following. And this concludes section 2.6, Input-Output Models.